So let's have a recap from yesterday's class. We started with understanding how we are connected uh, through the internet in our day-to-day life, right? And we just understood this particular topology, how our PCs through a wired or wireless medium is connected to the internet. And then we understood how a small office connectivity looks like, where multiple devices are connected to a single switch, which basically is an unmanaged switch. An unmanaged switch is a switch which you cannot control or you cannot manage. That's what you call it, as an unmanaged switch, right? So that unmanaged switch is connected to a router, then that router is connected to the internet. That's how what we saw. And we also discussed how in a corporate or in a big MNC or a big company, how different devices on different floors of the building are connected to the internet, right? So on all the floors, you may have one switch or multiple switches, right? And all those switches will be connected to a centralized switch. That centralized switch is then connected to a router, which takes you to the internet. This is what we saw. And then we discussed about the different kind of wires, their speed and their length, right? And then we discussed how these wires are twisted in a pair. So you have two types of twisted pair wires, which is called an unshielded and a shielded. For a shielded one you will have a protective coating, in an unshielded one you will not have a protective coating. And one of the wires in the pair will be transmitting, the other will be receiving. This is what we saw. And we saw what an RJ45 connector is, how it looks like, and how it is used to connect to a particular switch using a NIC or a network interface card. And these network interface cards are placed on the switches that we saw. And using these network interface card, you will connect it to the wires, right? And then we saw there the difference between an RJ45 straight through cable and an RJ45 crossover cable. So we saw if we are connecting two different devices, we use a straight through cable, and if you're connecting two similar devices, we use a Ethernet crossover cable. Right? We saw this yesterday, and then we saw about fiber optic cables and their IEEE standard names based on their distances. And then we moved on to the layer 2 switch, where we discussed a bit about switch, and then we discussed how different devices, networking device, use a layer 2 MAC address, which is a unique address to send data. This is what we saw. And we also saw how the MAC addresses are created unique in a way where 3 bytes are given by IEEE. The rest of the 3 bytes is given by the vendor. This is what we saw in yesterday's class. So continuing with that, today we will look into the working of a switch and how a switch uses MAC address to forward data. So in yesterday's class, we have been saying a switch uses MAC address to forward data, etc. So before we jump into the discussion, we have to understand a few things that I'll just start with now. But before I move on, any question from previous class?
I have one just a doubt.
Yeah.
Yesterday, when you were clearing a doubt, so you had told that the data that is fetched through IP address and not MAC address. So that I was a bit confused in that aspect.
Data is fetched to IP address and not MAC address. Okay, that question was from a cloud perspective. Okay, so
Huh.
as I mentioned, I'm not an expert in cloud.
No, no, not as a cloud,
Yeah.
but
Hmm.
data is maybe you if you go when you go with the switch, maybe I'll get the clarity that way. Okay. If I don't get, I'll ask you at the end of the session again.
You were asking about this particular thing, right? If I'm not
Yeah.
wrong.
So here it was termed out that only when it comes to cloud, right?
Not cloud, anything, not just cloud. Again, there was a participant yesterday. He had mentioned in the chat that cloud or the virtual MAC addresses work differently than the physical MAC addresses. Okay.
Got that.
which I am completely unaware. So the one that I said is how usually data transfer happens with physical MAC addresses.
Okay.
Okay. So what happens whenever you are sending a data or receiving a data, let's say even streaming. Okay, let's say this is a Netflix server rather than a normal server. Let's say this is a Netflix server. So whatever stream you do, right, your PC is actually making a TCP connection with the Netflix server. Okay, and that TCP connection is happening over the IP address.
Okay. Yeah, correct.
Right, and whatever data that you're sending, right, the IP address remains the same, but in yesterday the conclusion was the IP address throughout the journey of the packet remains the same. The MAC addresses at every hops keep changing. This is what the conclusion was in yesterday's discussion.
Okay.
I'm not sure if I answered your question, however. Yeah,
It's okay. If I'm not clear, I'll not forget to ask you again then.
no problem, no problem. So let's start our today's discussion. So in yesterday's class, we saw one diagram where a switch was connected to multiple devices, right? It was connected to different PCs, it was connected to different servers, etc. So let's take that diagram itself and take a switch and let's connect it with multiple PCs. PC number one, PC number two, PC number three, and PC number four. So switch is connected to different PCs. Right? Now, before we come to this particular discussion, I have few assumptions. Okay, before explaining this, I have few assumptions that I'm making to explain this. And these assumptions are just to make things clearer. The first assumption is that all the PCs, PC number 1, 2, 3, 4, they know about each other's MAC address. Okay, that's the first assumption, that PCs know about each other's MAC address. And second assumption is that uh, for a simpler explanation, I'm going to assume PC number one's MAC address as 1111, meaning all the digits in the MAC address is 1. Similarly, for PC number 2, all the digits are 2. For PC number 3, all digits are 3. And for PC number 4, all digits are 4. These are the MAC addresses of these PCs. And again, the first assumption that all the PCs know about each other's MAC address. Third assumption, the switch is unaware of these MAC addresses. Okay, so let me repeat the assumption. First assumption, the PCs, they know about each other's MAC address. Second assumption, you can see the MAC address written like 11223344, etc. Third assumption, switch is completely unaware of the PC's MAC address. These are the three assumptions that I'm making. So now let's consider, before I jump into the explanation here, let's consider a real-time scenario where I want to travel via road from Delhi to Chennai. This is my assumption, right? So let's consider a time when there were only those no smartphones were there. Okay, no Google Maps were present, etc. We completely relied on asking directions from one person to other and writing down those directions on our paper or a copy, whatever. So in olden times, obviously, when we did not had Google Maps, what we used to do, we used to collect the maps of each and every state that we cross. So Delhi, after Delhi, most probably we will go to Rajasthan, right? And then we'll go to Madhya Pradesh. Okay, then we'll come down to Telangana, if I'm not wrong, Telangana, Andhra Pradesh, and then we'll reach Tamil Nadu, and then finally Chennai. This is how we come down, right? So what we do is we keep a map of all these states with us, right? And before we start our journey, we mark all the important points and important roads that we are supposed to take, correct? So let's think from that perspective. So my source is Delhi, my destination is Chennai. Now when I'm noting down on the paper, what I will say, I have to start from Delhi. Obviously, I am living in Delhi. Okay, this is just an assumption. I live in Pune, but I'm saying because I live in Delhi, I know the whole the whole city of Delhi. I know how to go to Rajasthan. Correct. Anyhow, I will make a note of it. To reach Rajasthan, I will use some kind of exit highway or a exit highway number. For example, just examine NH 40. I'm just writing some random highway number. Okay, so I make a note of it. To reach Rajasthan, I need to use NH 40. Okay, then in Rajasthan, I reached the first city called as Jaipur. Okay, then I will make a note of it. From Jaipur, I need to take next NH, for example, 48. For example, to go to my next destination in MP, which is the city of Bhopal. It's the capital city of Madhya Pradesh. Okay. Then from Bhopal, I need to take another NH to reach Telangana. Then from Telangana, I will take another NH to reach Andhra Pradesh. Right. From Andhra Pradesh, I will take another NH to reach Chennai or Tamil Nadu, whatever. So if you think, we are considering two factors here. Okay. First is my destination. Okay. And to reach this destination, what exit am I using? What exit road or what exit path am I using out of each and every state or city to reach my destination? Correct. This is what our map look like, or whenever I am making a note. Okay, I will make notes like this. Anyway, there are few other times like go straight, turn right, you will have a city, take a right, etc. All that. I'm excluding all those intricacies, but I'm just giving you a high level overview of what we will do. A similar concept is what a switch will follow. Okay. So now thinking from this perspective, PC number one is, for example, Delhi. PC number two, for example, is Chennai. PC number one wants to send a data to PC number two. Okay. So obviously, when PC number one is sending a data to PC number two, it needs to have a source map. Okay. It needs to have a source address. Just like you're writing a letter. If you're writing a letter, you need to have a to address and you need to have a from address. Similarly, in networking also, you need to have a from address, that is source map, and the to address, that is called as a destination map. And the first assumption was all the PCs, they know about each other's MAC address, correct? So PC number's MAC address is 1111. PC number two's MAC address is 2222, correct? Now, let me also note down the interface numbers. In yesterday's class, we saw the switches have different ports or interfaces. These are those interface numbers. And these interfaces have wires that are connecting to the PCs. Now, PC number one, okay, sends that data, this data on the wire. It reaches the switch. Okay. So when the switch receives the data, okay, think from this perspective, you moved from Delhi and then you reached Jaipur. When you reached Jaipur, what are you going to check? To reach Chennai, okay, your destination is Chennai. What should be your exit road that will take you to, or that will take you a bit closer to your destination? That road is NH48, correct? So basically, if you see, you have a map in your hand. Okay. Similarly, a switch will also have its own map, which we call it as MAC address table. MAC table or MAC address table. Okay. And in this MAC address table, it will make a note of all the MAC addresses and the interfaces or port numbers. All right. So let's get into the technical discussion now. This data is received by the switch. Okay. What this switch does is, when the switch receives this data, first it reads the source MAC address. Okay. It reads the source MAC address and it finds out if this source MAC address is present in its MAC address table or not. And as per our assumption, the switch's MAC address table, as I said, assumption number 3, switch is completely unaware of all the PC's MAC address, correct? So switch's MAC address table is completely empty. So obviously switch is unaware of 111, but the moment it receives the data, it reads the source MAC address and it makes a note of it, saying that it has received a data with a source MAC of 1111 and it was received on interface number 1. It makes a note of it. Then, after reading the source MAC address, it reads the destination MAC address. It also checks, does it know about the destination MAC address or not? Okay, so you can see it does not know about the destination MAC address. Now, please understand how switch thinks. Okay, it does not know where to forward this data. It is completely unaware of how to forward the data. Okay, as human being, I think that I do not have a map. I have no notepad. I have no map in my hand. I'm just going through the direction given by people. Okay, so I reached Rajasthan. I reached Rajasthan, or I reached the city of Jaipur. Okay, then I asked one gentleman, like, I want to go to Chennai, or instead of that, I want to go to MP or Bhopal. Okay, obviously, if I ask someone how to reach Chennai, obviously they will not know. Okay, if I ask someone how in Rajasthan how to reach Chennai, they would not know. Obviously, I will have to ask the nearest destination there. So I asked how to reach Bhopal. So he would give me direction, go straight, take right, etc. Whatever. Okay, but if that person, whoever I asked in Jaipur, if that person does not know how to go to Bhopal, what is he going to say? I do not know. Please ask someone else. Right? Go ahead. Someone will tell you. This is what he is going to tell me. Okay. So as humans, we have this help. I can go ask someone else. But in networking, a switch, he does not have such kind of help. Okay. If he does not know how to reach this destination, okay, what the switch is going to do, switch will basically broadcast it out of all the interface. Switch is basically going to broadcast it out of all the interface with the expectation that someone with this destination MAC address will eventually receive it. Okay, why does the switch broadcast it? Obviously, in its MAC address table, it does not know about the destination MAC and it does not know how to forward it. Because it does not know how to forward it, it will broadcast it with the expectation that someone with this MAC address will eventually receive it. That is why the switch broadcasts. Okay. Now the switch has broadcasted that packet. PC number 4 will reject it. PC number 3 will reject it. Why? Because PC number 4 and PC number 3's MAC address is not 2222. Okay, their MAC address is not 2222. That is why they will reject it. And PC number 2 will accept it. Okay, is everyone clear till this part? Give a thumbs up, give a thumbs down, anything. Okay,
Laksh,
I
one
think everyone
question.
is clear. Yeah.
Yeah, so switch is going to broadcast this data, right? So during that time, it doesn't know that, like, how many PCs or how many devices are connected to switch.
Yes, I mean it will broadcast it wherever it has a link. Okay, so these
Okay.
PCs are connected through a wire, obviously, right? So it will send it out of all those connected links.
Okay, okay. And the MAC table will be loaded only when some action performed between the PC and the switch.
Correct. When the MAC table is populated only when the switch receives a data.
Okay.
Okay.
Okay. Yeah.
So Now, PC2 has received that data, the broadcasted data. Okay. Now, PC2 is going to reply. Okay. As a very friendly PC, obviously PC is going to reply. So when PC2 is going to reply, the source MAC is going to be PC number 2's MAC address 2222. Destination MAC is going to be PC number 1's MAC address 111. Right. And what will the PC do? The PC is going to send this data out of the wire and it will reach switch. Right. Now, again, the switch, when it receives the data, it is going to read the source MAC. Is this source MAC present in its MAC table? You can see in its MAC table, the source MAC is not present. So it makes a note of it. And at what interface was it received? It was received at interface number 2. So it makes a note of it. Then it reads the destination MAC. Does it know about the destination MAC? Yes, it knows about the destination MAC. And to reach this destination MAC or to send the data towards this destination MAC, it needs to send the data out of interface number 1. So now instead of broadcasting the data, this switch is now going to send it out directly to PC number 1 to the interface number 1. Okay. Now let's take another example where instead of PC number 1 wants to send a data to PC number 3, for example. Okay. The same procedure. PC number 1 sends the data to switch number 1. Switch, what it sees, first it reads the source MAC. Does it know about the source MAC? Is that source MAC present in its MAC address table? Yes, it is already present. So no action taken. Then it reads the destination MAC. Is the destination MAC present in its MAC address table? No. So what the switch is going to do, switch will be broadcasting it out of all the interface. Okay. PC number 4 is going to reject it. PC number 2 is going to reject it because their MAC address is not 3333. Right. So only PC number 3 receives this. When PC number 3 receives it, it will respond. When it responds, the source MAC is going to be 3333. Destination MAC is going to be PC number 1's MAC address 1111. Okay. Now, when PC number 3 forwards this data, again, the switch first will read the source MAC. Is the source MAC present in its MAC address table? No. So it will make a note of it. And it was received on interface number 3. Then it reads the destination MAC address. Is this destination MAC address present in its MAC address table? Yes. And to reach this destination MAC address, it needs to send the data out of interface number 1, and hence that data is received by PC number 1 again. Okay. Any question here?
How long does this data persist in the table?
It would be basically for 5 minutes. Okay, that's basically its refresh time. And nowadays, basically, it's there forever. Okay, unless there is a change in the receiving port. For example, now this PC number 2. Okay, now if this PC number 2 is no more connected here. Okay, instead of PC number 2, now there is PC number, for example, 5 with a MAC address of 5555. So, for example, what would happen from PC number 5? Okay, from PC number 2, there are no data being received at interface number 2, right? So it will be here, I think so, for 5 minutes. Okay, if I'm not wrong, let me confirm that tomorrow. It will be there for 5 minutes. Okay. If this data is not received, it will be erased from the MAC address. It will be erased from the MAC address. But again, if PC number 5 needs to be in the MAC address table, PC number 5's MAC address needs to be in the MAC table, PC number 5 needs to send the data. until and unless PC5 sends a data to the switch will never learn the MAC address of PC number 5. I hope I answered your
Yeah,
question
yeah,
and another thing as well.
yes, yes.
So let's look into a practical of this. Okay, before I jump into the practical, let me discuss one more thing. So there are three types of layer 2 traffic. Layer 2 meaning data link layer or the layer 2 of your OSI layer, okay, which the switch considers. First is a unicast. We all know what a unicast is. That is meaning one-to-one communication, okay, where there will be a source and there will be a destination, okay. Then there is something called as broadcast. The broadcast that we saw in our example is not the same broadcast. I'll explain why in just a minute. So here in this broadcast, there will be a source MAC and there will be a destination MAC, but in the destination MAC, the value of destination MAC will be all F. All the digits of your MAC address is going to be F. This FFFF will not be present in your MAC address table, and it is not necessary also to be present. The moment the switch reads the FFFF as the destination MAC, it will automatically broadcast the data out of all the interfaces. Okay. And the third is called as unknown unicast. Unknown unicast. Okay. So there is a source, there is a destination, and hence it is called as a unicast. However, this destination MAC address is unknown to the switch. That is what we saw here. In our first example, or let's take the same example. Okay. So if you see, switch, the PC is sending a unicast data, which has a source MAC, which has a destination MAC. But the switch is unaware of the destination MAC. That is why it is called as an unknown unicast. And how is an unknown unicast treated by the switch? The switch treats an unknown unicast as a broadcast only. Correct? We just discussed if the MAC address is not present in the MAC address table of the switch is basically going to broadcast it out of all the interface. So an unknown unicast data is treated as a broadcast by the switch. So all this traffic is completely dependent on the MAC address table. The source is present, destination is present, it's a unicast. The source is present, but the destination MAC address has all letters as FFFF, then it's a broadcast. The source MAC is present, but the destination MAC is not present in the MAC address table. It's called as an unknown unicast, and the switch will treat or broadcast it out of all the interfaces. Okay, so three types of traffic: unicast, broadcast, and unknown unicast. So we'll see all that now. So let's take the same example. 4 different PCs. PC number 1, PC number 2, PC number 3, and PC number 4. So if you're wondering what software is this is Cisco Packet Tracer. This is freely available to download from Cisco site. All you need to do is create a Cisco login credential, and you will be able to download. So let me give IP addresses to these PCs. 10.0.0.1, PC number 2, 10.0.0.2. We will discuss IP address later, but just for now, let's just assume I'm giving IP addresses to these PCs. 10.0.0.3 and 10.0.0.4. So these are the IP addresses for these PCs. Okay. So the assumptions that I made, right? That all the PCs are aware of each other's MAC address, right? Second assumption was obviously the second assumption where I said PC1's MAC address is 112233. I do not have the control over it. In here, I do not have the control. So you can see this is this is the MAC address, okay, of the PC. This actually is not exactly the MAC address. This is an IP v6 link local address. We will talk about IPv6 later, but just for your understanding, PC1's MAC address ends with E52. Okay, PC1's MAC address ends with E52, 0E52. Okay, PC2's MAC address ends with 0875. PC3's MAC address ends with E9B2. Okay, just consider the last four digits whenever I'm explaining. So as I said, the second assumption where 11223344, I do not have the control. So let's ignore that assumption. Okay. So the first assumption, all the PCs should be aware of each other's MAC address. How can I do that? I will have to do a ping between all the PCs first so that each of them know about each other's MAC address through ARP. We will discuss ARP later, but just remember to exactly simulate this condition that we have discussed, I will have to ping or send some kind of data to all the PCs so that they will know about each other's MAC address. Okay, so I will ping from PC number 1 to PC number 2. I will ping from PC number 2 to PC number 3. From PC number 1 to PC number 4. Okay, then from PC number 2, 3, 4, etc. I'll have to ping 10.0.0.3 and ping 10.0.0.4 and between 3 and 4 as well. Ping 10.0.0.4. So I have pinged each PCs, okay, with the ping and ARP, they will know about each other's MAC address. Okay, that was a first assumption that all the PCs should know about each other's MAC address. Second assumption was the MAC address as 112233, which we are completely ignoring. Okay, now coming to the third assumption where the MAC address table of the switch should be completely empty. So if I do a show MAC address table, we will see the MAC address table is not empty. So I will have to clear the MAC address table. And this is because I pinged each PCs and that is why their MAC address is populated. Now the MAC address table, if I check after clearing, it is empty, right? And you can see in the MAC address table, the two most important columns are MAC address and the port. Okay. Now, before I jump into the practical, any question till here? Okay. Another thing, is my speed okay? Or do you want me to slow down or speak fast? Anything? Ganesh, Gangadhar.
It is good, Laksh. We are able to
Okay.
follow.
All right. Fine. Ganesh, are you okay with the speed?
Yes.
All right. No problem. Arti, I hope it's okay with you also.
No, it's okay with me. I just wanted to know is like I am not aware of Cisco packet tracer. So prerequisite, what are the prerequisite? Just can you tell me at the end of this session?
Yeah, sure, no problem. No problem. So let's simulate that same thing. So what I'm going to do, I will ping from PC number 1 to PC number 2. Okay, and let's see what happens. Ping PC number 2. Okay, the moment I did a ping, we can see that PC number 1 has created a packet. Okay, it created a packet, and let's check the outbound detail. Outbound detail means outgoing details, and we are only going to check the layer 2 details. IP is a layer 3, ICMP again is a layer 3 protocol. Okay, these are all. We will, for now, let's ignore these details. Let's just concentrate on Ethernet layer or the MAC addresses. So you can see we have a destination MAC address and we have a source MAC address. This source MAC address is of PC number 1. This destination MAC address is of PC number 2. So as I said, each PCs, they know about each other's MAC address, and hence PC number 1 knows about PC number 2's MAC address. That is the destination MAC address. So you have a destination MAC address, you have a source MAC address, right? Now the PC sends this data to the switch. And as I said, what the switch does, the switch will first read the source MAC address. Is this source MAC address table, source MAC address present in the MAC address table? Correct. So the source MAC address here, source MAC address here is 0E52, right? And we cleared the switch's MAC address table, right? So it was not present. Now, if I check, if I do a show MAC address table, we will see that the switch has made an entry for 0E52. That's the source MAC address. And it was received on fast Ethernet 0/1. Correct? So it made a note of the source MAC address. Then the second thing, it will check the destination MAC address, right? The destination MAC address is 0875. Is this destination MAC address present in its MAC address table? No. So if the destination MAC is not present in its MAC address table, it will broadcast it. Okay, it will broadcast it out of all the interfaces. And look, that's what it did. It broadcasted it out of all the interfaces, right? So PC number 3 and PC number 4, they rejected this data because that is not their MAC address. PC number 4 and PC number 3 rejected it. Who accepted it? PC number 2. Let's check what is PC number 2's information. So when PC number 2 is sending that data, why is an ARP? Why is an ARP generated? We did a ping from PC number 1 to PC number 2. Yeah. So why is it an ARP generated? That's odd. It should not have generated. Okay, that's pretty odd. It should not have generated an ARP. Let me clear the MAC address once again. Simulated. Which receives it, which makes a note of the source MAC address, broadcasts it out to all the PCs. Okay, PC3 rejects it, PC4 rejects it, PC2 accepts it, right? So when PC2 accepts it, this is the inbound detail, meaning incoming detail. You can see the destination MAC as 0875, which is PC number 2's MAC address. Source MAC address, you can see PC number 1's MAC address. Now, when PC number 2 is replying, we will see the MAC addresses exchanged. So we can see 0E52 is now the destination MAC address, which is PC1's MAC address. This is PC number 2's MAC address, that is the source MAC. Okay. This data is sent back. Now, the switch, what it will do, it will read the source MAC address, right? The source MAC address, that is the source MAC address, that is 0875. Okay, is 0875 present in the MAC address table for the switch? It was not earlier, right? So it makes a note of it. 0875 was not present, so it made a note of it. And on what interface was it received? 0/2. So it made a note of both the things, the MAC address as well as the interface, right? Then it checks the destination MAC address. The destination MAC address is 0E52, right? 0E52. 0E52 is the destination MAC address and it's present in the MAC address table. And to reach 0E52, it needs to forward the data out of 0/1, and that is what the switch does. It will forward the data directly to 0 from 0/1, and it will reach the PC. Now, whatever data is being exchanged between PC1 and PC2 will be a unicast. So PC number 1 sends the data, it reaches PC number 2, there is no broadcast. PC number 2 sends back the data to switch number 1, it sends it directly to PC number 1. Okay, you can see the data are being sent like that. So here we saw the example of an unknown unicast where PC number 1 where the PC number 1 sent a data. So okay, PC number 1 sent a data. Switch 1 made a note of the MAC address. Okay. Switch 1 was completely unaware of destination MAC address, so it broadcasted it out of all the interface. This was an example of unknown unicast. Unknown unicast, where it was a unicast from PC1 to PC2. However, the MAC address, the destination MAC address was unknown. That's why it was an unknown unicast. Okay. Then when PC number 2 replied, the switch made a note of the source MAC address, right? It knew the destination MAC address of PC number 1. So this was a unicast for the switch, and it forwarded it directly to PC number 1. Okay. Now, if you want to see a broadcast, let me add one more PC here. And give it an IP address 10.0.0.5. Okay. I'll show you the broadcast. I'm waiting for this link to come up. Now from PC number 5, let me ping PC number 1. Ping 10.0.0.1. Okay. So the moment I did so, you can see there are so many packets that PC number 5 has generated. The first packet you see here is an ARP packet. We will discuss ARP later. Okay. But here, see the destination address. It is FFFF. All the digits of the destination MAC address is FFFF. This is a broadcast packet. This is not an unknown unicast. This is not a unicast, but this is a broadcast where the destination MAC address itself is FFFF. And how does a switch treats a broadcast? Obviously, it is going to broadcast it out of all the interface. It did that. And what is this? It is also an ARP. Okay, so you see A broadcast packet is sent to, and the broadcast packet necessarily is not present in the MAC address table. You will not see FFFF present in the MAC address table. It's the inbuilt feature of the switch where it reads the broadcast MAC address FFFF, and it automatically knows that it needs to send this to everyone that it is connected with. Okay. Any question here?
I have one, Laksh. So,
Yes.
for example, when at the start, PC, we were pinging all the PCs from PC1, right? So, PC1, we
Yes.
pinged PC2.
Hmm.
Why broadcast was not happening at that time at it,
Hmm. Hmm.
and when
So
PC.
broadcast was happening. Broadcast was happening. I did not show you.
Okay, okay, okay.
Okay. So as I said, I made an assumption, right? First assumption where PCs know about each other's MAC address. Okay. They will not know about each other's MAC address until unless they do a broadcast ARP.
Okay. Hmm.
Okay. Until unless they do an ARP request. PC5, when I did a ping, it sent an ARP request, which was a broadcast. Similarly, when I did a ping from PC1 to PC2, PC3, and PC4, etc., it first generated an ARP packet. That's why PC1 knew about each other's MAC address.
Okay.
Similarly, all the other PCs knew about each other's MAC address. I did not show you that part.
Okay. I got it. Thank you.
Okay. As I said, we'll discuss ARP later when we start talking about routing. Okay. We'll discuss ARP there. So let's move in to the discussion when two switches are there. Okay, this we saw when there was one single switch, what would happen. Let's see what will happen if two switches are there. Okay, so PC number 1, PC number 2, PC number 3, PC number 4, PC number 5, and PC number 6. Okay, I'm writing down their interface numbers: 1, 2, 3, 4, 5, 6. This is 7, and this is 8. Okay. Now, again, the same assumptions. All the PCs, they know about each other's MAC address. The switches are completely unaware of the PC's MAC address. Their MAC address table is completely empty. Okay. So this is switch number 1's MAC address table. Okay. And this is switch number 2's MAC address table. All right. Now, PC1 is trying to send data to PC number 5. Okay. So source MAC is 1111. Destination MAC is 5555 because we are trying to reach PC number 5. Okay. Now, PC number 1 sends the data. Okay. It hits switch number 1. So what the switch will do? Switch will first check if the source MAC address is present in its MAC address table. It is not. So it makes a note of it, and it will see on what interface was it received. It was received on interface number 1. Right. Then, does it know about the destination MAC address? No, it does not know about the destination MAC address. If it does not know about the destination MAC address, what does it do? This is an unknown unicast, and unknown unicast is treated as a broadcast. So the switch will broadcast this packet out of all the interfaces. Okay. Now this packet then eventually reaches switch number 2. Okay. So the switch number 2, it does the same thing. First, it reads the source MAC address. Is it present in its MAC address table? No. So it makes a note of it, and on what interface was it received? It was received on interface number 8. Then it reads destination MAC address. Is the destination MAC address present in its MAC address table? No. So it will broadcast it out of all the interface. Obviously, PC number 2, PC number 3, PC number 4, and 6, they will discard this packet or reject this packet because that's not their MAC address. Okay, 5555 is not their MAC address, and hence they will discard this packet. Okay, I hope everyone is clear till this part. Now, when PC number 5 replies, okay, when PC number 5 replies, the source MAC is going to be 5555. The destination MAC is going to be 1111, which is PC number 1's MAC address. PC number 5 responds. Switch 2 receives it. Switch 2 will see, does it know about the source MAC address? No. So it makes a note of it. And it was received on interface number 5, right? Then it checks the destination MAC address. Does it know? Yes, there is an entry. And to which interface should it be sending? Interface number 8. So switch number 2 forwards this data out of interface number 8 and it reaches the switch number 1. Switch number 1 will first again read the source MAC address. Is it present in its MAC address table? Yes. So there is no need, sorry, not this one.
5555.
5555, yeah. 5555. Is it present in its MAC address table? No. So it makes a note of it. Okay, and which interface was it received? 7. Then, does it know about the destination MAC address? Yes. Which interface should it be forwarding out of? Interface number 1. So this is how basically your switches receive the data and forward the data. Okay, any question here? Let's do the same practical using 2 switches. And the same thing where all the PCs know about each other's MAC address. So Aarti, let me show you. When I do the ping, right? Let me first assign these IP addresses. When I do the ping, they will generate a broadcast. PC number 7. PC number 8. So from PC number 7, I am pinging for PC number 1 for the first time. Ping 10.0.0.7. No, so 1. Okay. So you see here.
Yes.
So it has generated an ARP which has a broadcast MAC address.
Yeah.
Okay. So I did not show you that the first time. Okay. So from PC number 7 to PC number 8, PC number 6 as well. Okay. Now, since I have pinged the devices, obviously all the switches will know about each other's. The switches will know about PC's MAC address, correct? So what I should be doing, I should be clearing the MAC address table of these switches. Clear MAC address table. Okay. Then again on this switch as well, if I do a show MAC address, show MAC address table, you will see the MAC addresses. Okay. So I will clear the MAC address table because I want to simulate the same condition. Right. Now, if I do a show MAC address table, you still see one MAC address. Okay. You will not see any other MAC address, just one single MAC address. Similarly, on switch number 1 also, you will see one MAC address. Show MAC address table. Okay. This is not of any other PCs. These MAC addresses on this switch, switch number 2, we are seeing this interface MAC address. Similarly, on switch number 1, we are seeing this interface MAC address. Basically, we are seeing each other's interface MAC addresses. This is because of a feature called as CDP, Cisco Discovery Protocol, which we will discuss later. But because of CDP, it's an default feature in Cisco devices. They will know about each other's interface MAC addresses. That is the only thing they know about. So, anyway, switches are completely unaware of PC's MAC address, right? The rest of the things remain the same. So let me ping from PC number 1 to PC number 7, and let's see what happens. Ping 10.0.0.7. Okay. So when I did a ping, a packet is created. We have a destination MAC, which is PC7's MAC address, source MAC, PC1's MAC address. Okay. So this is received by the switch. Switch's MAC address table is empty except for switch number 2's MAC address, which we are going to ignore for now. Okay. So the destination MAC, first it reads the source MAC address. That is 0E52. Is 0E52 present in the MAC address table? No, right? So it would have made a note of it. 0E52, it was received on 0/1. Then the destination MAC address is 8586. Is 8586 present in the MAC address table? No. If the destination MAC address is not present in the MAC address table, the switch is going to broadcast it. It did it. So PC number 4 receives it, PC number 2 receives it. They will discard the packet because that's not their MAC address. Switch number 2 receives this packet, right? It makes a note of the source MAC address. Show MAC address table. It makes a note of 0E52, which is the source MAC address, and it was received on 0/1 interface, right? The destination MAC address 8586, if I'm not wrong. Yeah, destination MAC address 8586. It's not present in the MAC address table. So the switch needs to broadcast this as well. Switch number 2 will broadcast it also. PC number 8 and PC number 6 discard this packet because that's not their MAC address. PC number 7 will accept it. PC number 7, when it is responding, we will see 0E52 is the destination MAC address, which is PC1's MAC address. 8586 is the source MAC address, that is PC7's MAC address. Correct? This data is sent to switch number 2. Is switch number 2 aware of 8586? That's the source MAC address. Correct? Is the switch aware of 8586? No, it is not.
No.
So it will make a note of it. 8586. It was received on 0/3. Then 0E52 is the destination MAC address. Is the destination MAC address present in the MAC address table 0E52? Yes. So it does not need to broadcast it. It will directly send it out of that interface. It is not sending to the switch. It is only forwarding or sending it out of that interface. The switches are completely unaware of what the device is that is connected on that interface. Here, it can be a router. Okay, it can be a router. It can be a PC. It can be a server, anything. The switch only knows it needs to send the data out of this interface. That's all it knows. Okay. So now switch 1 receives it. Does switch 1 knows about 8586 in its MAC address table? We can see it does not know. So obviously it would have made an entry for it. 8586, yes, it has made an entry and it was received on 0/3. Does it know about the destination MAC address, that is 0E52? Yes, it knows about 0E52 and it needs to send it out of 0/1. So it forwards the data out of that to PC number 1. And this is how the switches, they talk to each other. Okay. Any question?
I have one. So in that MAC address table, If you could open one of for switch. Yeah. So here, from the same port, there are two MAC address table. So that it's not a issue, right? It can
No, it
happen
is
like
not. It can happen. See, let's say I have another switch here, okay, and then there are multiple PCs connected. So obviously, what is happening? These PCs MAC addresses as well as these PCs MAC addresses are learned by switch number one on this interface only. Correct? So let me do a ping from PC 8 to PC number 1. Ping 10.0.0.1. Okay. So PC 8's MAC address, let's just check 1E70. It ends with 1E70. And now let's check the MAC address table. 1E70 0/3. 0/3. So it's not that you can receive only one MAC address on one interface. You can
that.
have multiple MAC address on the same interface.
Okay.
It's just like this is an
That is
entry
only
point.
when it comes to switch, right? When it comes to switch.
Yes, when it comes to switch, yes. No, even on routers also, you can have multiple IP addresses received on one single interface.
Okay.
Right. It's just like this is one single entry point and one exit point. Right. Similarly for router also, this is one single exit point and entry point. So you can reach any network out of this interface.
I mean, any networking device that way, right?
Yes, it's true for anything.
Okay.
Gangadhar, Ganesh, any question?
No, Laksh, got it.
No, no, sir.
All right, no problem. Thanks. So I think this is it for now. Tomorrow we'll start with VLANs. Okay, we will start with VLANs where we will discuss what are access ports and what are trunk ports. Okay, before I close today's call, let's just discuss few things. Are you guys aware of the CLIs of the switch?
No.
Are you guys? No. Okay. So let me bring in a new switch here. So here, when I open this switch, you will see some kind of information loading. This is called as the CLI or the command line interface, CLI, command line interface. And whenever I will also show you how do you actually connect a PC and a switch or a PC and a router physically. Okay, but for now, I'm skipping that part. Okay, and I'm directly jumping into the command interface of the switch. So whenever you power on a switch, you will see such kind of information. Okay, it's just the same way whenever you power on your laptop, you see your company symbol, Lenovo symbol, HP symbol, Apple symbol. Okay, in olden days when we had this box PCs, right? There was an Intel symbol, Intel, and there was a star. If I'm not sure if you guys remember this, there will be a star symbol, right? Those were the times back then, right? So it's the same way. Whenever you power on a switch or even a router, for that matter, you will see some kind of boot or booting messages. So here again, this is not important from CCNA point of view. This is just important from a network engineer point of view. Okay, so you can see what kind of switch is this. Okay, example, I use a OnePlus phone. Okay, so if I'm using a OnePlus phone, here it will show me OnePlus. Right. Similarly, this switch is a C2960 switch or a Catalyst 2960 switch. Okay, and it is running this version, 12.2 version, and this is the model number, exact model number of this switch. Okay, what is the processor number? You can see all that. What is the MAC address of this switch? You can see that. Okay, and then there are a few other information which is not necessary for us to know. Okay, and then if you scroll down, you see this information where again you will see the MAC address, you will see the motherboard number, power supply number, motherboard serial number, power serial number, etc. All that information is present. Why are these information important? So let's say that uh, the switch had some problem. Okay, the switch has some problem. So you call the support. Okay, you call the vendor support, and they will ask, right, what is the serial number of this switch? So you can just log into the switch and check. If you run, if you can give these serial commands: motherboard serial number, power supply serial number, the MAC address, etc. So with that, the customer support guys can pinpoint the model number and the version number, etc. Through those uh, uh, through these information. That's why it's important. Other than that, from a troubleshooting point of view, this is not at all important. Okay. Now, once this log is created, be it a switch, be it a router, you will always see this line. Press return to get started. Press return to get started. Return here means press enter. Okay. Or I think in Mac laptops, it's called as return only, if I'm not wrong. Okay. So press enter to get started. Okay. When I press enter, you will see this prompt: switch and a greater than or a less than symbol, whatever you want to assume. Okay. Switch and a greater than or a less than symbol. This mode, when you press enter, this prompt and this mode is called as a user mode. Is called as a user mode. Okay. What is a user mode? First of all, a user mode gives you limited access to the switch. Okay, what kind of limited access? It gives you only read access. Read only access. Okay, what information can you read? If you want to read any information on the switch, okay, most of the time you will run a show command. Show will give you all the outputs that you need. Okay, now after show command, if you enter question mark, it will show you all the syntaxes that you can type after show. You can write show ARP, show CDP, show clock, crypto, ether channel, MAC address table, version, VLAN, VTP, etc. So if you type show version, it will give you this information that we were discussing earlier. Okay. If you do a show MAC address table, it will show you the MAC address table. We are checking switch number 3 currently. This switch, which is completely, which is not connected to anything. That is why the MAC address table is empty for now. You can see the MAC address table. So, and if you just press question mark without typing anything, you will get these options: disable, disconnect, enable, logout, ping, resume, etc. Okay. Now, who are given this user access, and why, first of all, is a user mode given? And in user mode, why is there only a read access, read only access? Because sometimes what happens, imagine you are a customer, okay, and this switch is connected to different PCs. Okay, this switch is connected to different PCs, and there are sensitive information, and something went wrong with the switch. So you call the support, okay, and the support team said, I would like to look into your switch. Okay, so you would give him only the user mode access. You will give him only the user mode access, which will only give him limited access to the device. Okay, limited access to the device. He cannot check the configuration of the switch. He can check only limited things, to which devices it is connected, what VLANs are running, what's the version, what is the MAC address table, etc. Nothing more. Very limited information he can do, and he can only read the information through the show command. Okay, mostly we will always use show command. Show R, show CDP, show sessions, show MAC address table, etc. Nothing much. Okay, this is called as the user mode. Now, if I want to configure something on the switch, if I want to make changes on the switch, I want to configure VLANs, I want to configure spanning tree protocol, I want to configure something else, how do I do? Because in the user mode, there is no way where I can configure. There's no way that I can configure. So I go into the execution mode. Okay, I go into the execution mode. If I enter question mark, not execution mode, privileged mode. Privileged mode. Okay. Okay. The mode that we are currently on, switch this one. This is called as a user execution mode, not just user mode. It's called as a user execution mode. Exit. User execution mode. And if I want to configure something on the switch, I will have to get inside the privileged mode. Okay. Privileged mode gives me read and write access both. So if I type enable, I will get inside the privileged mode. And the first change that you will see is the prompt. From switch less than or greater than symbol, it turns to a switch hashtag. This means you are in the execution mode. Okay, you are in the execution mode. Now, in this execution mode, what's the major difference? Major difference is, let me just type question mark. Okay, in question mark, you may not see that difference. Show question mark. Okay, just see the amount of things you can check through show command. Show access list, show ARC, show boot, show CDP, show history, show interfaces. Okay, show port security, show monitor, show running configuration. Running configuration means the configuration that is running on the switch. Okay, you can check all those things. You can also configure on the switch. Okay, you can make changes. So not only you can read the information, you can also write the information or make changes in the information. To make changes in the information, you have to enter the configuration terminal. To enter the configuration terminal, you need to write this command, configure, then terminal. Okay. And from here, you can make changes on the switch. You can add VLAN, you can delete VLAN, you can change the switch name, etc. Anything that you want to do. Basically, you are writing the switch because you are given the right access. Okay. And the first change that you would see is from switch hashtag, it has gone to switch config hashtag. Okay, in brackets, which means you are in the configuration mode or configuration terminal. If you want to exit out of this, just type exit and you are back to the execution mode. Okay, so configure terminal. Okay, now if I want to, I'm just starting with the very basic. If I want to change the name of this switch, the name of the switch is currently switch. I want to change the name, right? Host name, let me write it as CCNA. So the moment I do so, you can see the name has changed to CCNA. Previously it was switch, now it has changed to CCNA with the command host name. host name CCNA. Okay, if I want to change it back to the same name, host name switch. The name has changed back to switch. Similarly, you can make such changes. Okay, as we move on to different topics, you will automatically understand different commands. I'm not bombarding you with all the commands today itself. I'm just taking it very slow. Okay. One more thing which I want to say. Mm, So, yeah, if I press enter, it will not enter, exit. If I type exit, it will exit out of the configuration mode. So, what kind of configuration you should do, etc. We will slowly start learning as we get inside these things. Okay. Any question up till here? How do you connect a switch and a PC? That's for another discussion because I will have to physically show you on the video. Okay, give me some time. I'll arrange something and you will be able to understand. Okay? Because this is software. Software makes it easy for us to open this. But in reality, this is not how it actually works. Okay. Any question?
No, clear with today's topic.
All right. Thank you, Aarti. Ganesh, Gangadhar.
As of now, no doubts.
All right. Thanks.
Yeah,
Thank
clear,
you.
Laksh. Yeah.
Thank you. So let me stop.